Hi guys, welcome back to my channel Programming in Pirai. In this video, we are going to see about how to implement a stack using a linked list. So see here, what is meant by stack? So stack is some data structure in which we use like a last in first out technique. The lastly inserted value is taken out first. So if I have a stack like this, basically stack is visualized like this. Okay, now if I put 1, 2, 3 inside my stack, so when I take it some element from the stack, I can take what? The lastly inserted element as first and the firstly inserted element at last. Okay, this is what a stack meaning. And what is my linked list? So linked list is something like a dynamic array, but it can store what? It can store whatever the attribute we give. Okay, we will implement by using what? Class, or in C we implement by using what? As structures. Okay, and if you know about this linked list, I will give the link in the description. Just go and watch that video and resume this. Fine. Now, there are some basic operations in this stack, namely push, pop, and front. So these are the operations we can do in stack. Okay. So to implement these three basic operations, we need what? This linked list. That's the topic today. So basically, the stack can be implemented by using what? An array and also a linked list. Okay, but the disadvantage of this array is what? It is a fixed size. It is a fixed size. That's why we are going to what? This linked list. Okay, other than that, these both are same. Now, let us understand this. Initially, I have something like a top pointer. You may ask, what is this top pointer? This top pointer is something like it only maintains what is the top element in that stack. So, for example, if this is my stack, take for example, this 3 is not there. Okay, now I can say this 2 is my top, right? So my top will point to this 2. Can you understand this? Fine. Now initially it is what? None, because we don't have anything, right? Okay, initially it is none. Okay, take for example, I give you a command like just push a value called a 10. Okay, then I will create a value 10. I will create a value 10 and I will make this top to move to this 10. Can you understand this? This 10 is like what? A 10. And this next address is what? A none. Next address is none. Again, if you don't know about a linked list, just go and watch my video so that it will be more clear and resume this video. Okay. Now, I want to push 1 again. Okay. If I want to push 1, just hold down. 1 will be where? 1 will be in my top, right? Just take for example, this is my stack. I pushed it 10. Now it's time to push what? 1. Now my top is what? 1, right? So I will include a 1 here and make its connection to this 10 and make this top to move to this 1. Can you understand this? So now this 1 is like what? 1, and next address is what? This 10's address. Take for example, if this 10's address is something like 100, then this should be what? 100. Can you understand this? Yes. Now again, I will give a push operation for a 20. Then I will insert a 20 here, and next will be what? This 1's address, and make this as what? My top. Now I'm asking a front operation. I'm calling a front operation. Then what should I return? I should return this 20. So I should return what? A top's value. So I should return what? The top value. What is the top value? That should be returned. Can you understand this? So this front is over, and this push is also over. Now this front is not still over. I'll tell you some edge cases. Okay, this front is partially over. Take like that. Now we are going to do what? A pop operation. Okay, what's my linked list as of now? It is like 20, then 1, then 10. Right? Now my top is where? My top is at this 20. Okay. Now listen carefully. This is a turning point. See here. I want to pop it, right? So if I pop it, this 20 will be erased, and this 20 will be returned, right? So I will return this 20. That's easy. That's called what? This front operation is, that's right. Okay, but how to delete this 20? Okay, I will make this top to move here. And delete this node. I will free this node. I will free this space, or delete this class. Delete this object. If you are using a C or C++, just free it. If you use a structure, if you use a class, just delete it. Simple, right? Simple. Okay, now I move to what? This place. Now again I am calling a pop operation again. So for first pop operation, it is 20. Now if I call again a pop operation, what is my output? My output will be 1 and my top will be go to what? This 10. Yes, again I am calling this pop operation. Then I should do what? 10. And what's 10's next? 10's next is none, right? So my top will be moving to this none. Can you understand this? Again I am calling this pop operation. Then I don't have any node, right? I don't have any value. So I want to return what? I want to return or I want to print like nothing is there. Nothing is there. So in technical term, it is what? Stack underflow. Stack underflow. Can you understand this? So you want to return this or print this. Okay, when my top is equal to my none. So my top is where? Now none. Okay. Now if I do a front operation, this front operation should also do what? Should also print what? My stack as empty. My stack is empty. So can you understand this? Now we will build this all functions, right? Now let us see the code so that it's more clear. Now this is the concept behind it. Can you understand this? Now try to write this code by yourself. If you don't write or you cannot write this, just watch my video for further. Okay. Now see here. So this is my code. Okay. As include of stdio.h. Now as include of stdlive.h. So I'm using this to implement a structure and also using a malloc function, right? I'm using a malloc function. So using this to use this, I'm using this stdlive. Okay. Now struct node of int data and struct node of next. So this is my what? My linked list. My linked list will contain what are the attributes? My linked list contain a data attribute and also the next address attribute, right? So that's why I'm creating this too. Now struct node star top is equal to null. So initially I will make the top is what? A null. That's what I mentioned there, right? Okay, now void push of int val. What should I do if I pushing a value into the stack? I should do like I want to create a new node. I want to create a new node. How to create a new node? Struct node star temp is equal to struct node star and malloc of size of node struct node. So this is the data type or this is the one sentence to create a node, right? So this temp is what? Now a newly created node's address, right? Now this temp's data should be what? The value that is given by the user, and temp's next should be pointing to where? Pointing to the top, and the top should be pointing to where? Towards the temp. Can you understand this? If take for example, if I have like 10 already, if I want to insert a 1 here, if it is a top, then I want to insert 1 and point to this top. Then I want to make this top to move where? Move here. That's what I have done here. Can you understand this? Yes. Now I want to write a pop operation, right? To write a pop operation, first step, I want to check whether it is equal to null. The top is equal to null. Then I should print what? Stack underflow. And I should return what? A -1. There you can return any one. I return what? -1. That's it. Okay, now else what should I do? Struct node star temp is equal to top. So I am taking the top value and int val is equal to temp's data. So I am taking the data of that top value inside what? Val. Now top is equal to tops next. So I am moving my top to what? The next element, and I am going to free my temp, which means what? I am deleting the temp node. Now return the value. That's it. So because while popping, we should return the value also. We should delete it and also return it. Okay. Now int front. So in front, what we are going to do? Now in front, we are also checking whether the top is equal to null. If it is null, I should print what? Stack is empty. Else I should return what? Top data. The top data should be the return value, right? That's what I written here. Okay, now this is a main function. Main function is simple class. Simple functionality, like whether you want to decide whether exit, print, pop, or push, like that. So I just print. I'm just printing the instruction. Then I'm just doing it until what? Until I get the ch is not equal to 4. Okay, now I'm getting the choice, and in the choice, if it is 1, I want to do what? I want to get the element, and I want to call a push function. If it is 2, I want to print the pop function. If it is 3, I want to print the print function. Simple. So let me run it. Fine. Now let me push it. First I'm pushing what value? Maybe a 10. Yes. Now again I'm pushing 1 again. Now again I'm pushing 20 again. Okay, now I'm going to pop it. So when I'm popping it, now what should be the value that is popped out? So initially 10, then 1, then 20. So 20 should be the answer, right? So I'm popping out. So 20 is the answer. Now I'm going to take the front. So now front is what? 1. So front is 1, right? Now I'm going to again take what? A pop operation. So pop operation will be what? 1, right? Now again I'm doing a pop operation. It is 10. Now when I again do the pop operation, it is what? Stack underflow. Stack underflow. Okay, I'm doing what? Again a the front operation. So it will what? Stack is empty. Okay, I said I am just stopping here. That's it. Can you understand this? So the main advantage of using this linked list rather than the array is that the stack won't become the overflow, which means what? The size is not fixed. It is what? A dynamic. The size is what? A dynamic. That's why we are going to use what? A linked list. We can also use a dynamic array also. You can use a dynamic array, but still this dynamic linked list is also used. Now, the main thing you want to understand is that the time complexity of this program, right? So in how much time it takes. So I can say what we are doing, we are just adding in my start. So it is like inserting in a start. So insert at start will require how much time? Will require the time complexity of what? Work 1. It is what? A constant operation. It is what? A constant operation. Can you understand this? So time is what? Like a fraction of second. It don't even take a time. Like it don't even take a growth. Okay, it is like a constant. So if I put a graph for it, the graph will be like what? A graph will be like this. A slanting line. That's it. There will be no growth. No growth. So this is what? A constant time. So it takes only constant time. So it is a better approach. Right? Thank you.